Okay, let's talk about something really cool. We're talking about an AI that can look at a piece of fruit and know with almost perfect certainty if it's ready to eat. This is the story of how a new kind of AI learned to grade dragon fruit better than almost any human alive. So, this is the dragon fruit. For farmers, especially in places like Vietnam and Bangladesh, this isn't just a fruit. It's a global expert superstar. It's their livelihood. But if you look closely, each one of these holds a secret, a kind of biological clock that can literally make or break an entire harvest. Yeah, the difference between profit and loss can come down to a single judgment call. And here is the absolute heart of the problem. Dragon fruit is what's called non-climacteric. Now, that's just a fancy way of saying that, unlike a banana you bring home to ripen on the counter, a dragon fruit stops ripening this second you pick it. There are no second chances. Pick it too early, it's raw forever. Pick it too late, it's already spoiling. The timing has to be perfect. So you can see how this creates a huge dilemma, right? You've got these immense financial pressures on smallholder farmers. They're trying to meet these incredibly strict quality standards for the international market, and one bad call can just threaten their entire livelihood. And this is the part that really matters. When a shipment gets rejected, because a few bad fruits slip past inspection, it's not some big corporation that eats the cost. No, that loss falls directly, 100% on the farmer. It's a system with zero room for error, and the human cost is just incredibly high. Now, you'd think with stakes this high, there'd be a foolproof system in place. But the truth is, the old ways of doing things are really starting to break down under the pressure of the modern supply chain. On one side, you have people grading by hand. But humans get tired. One person's ripe is another's almost ripe. The inconsistency is a huge problem. Then, on the other side, you had these early AI models. But they were total black boxes. They'd spit out an answer, but they couldn't tell you why. So farmers just didn't trust them. And worse, a lot of them were trained on messy, duplicated data, which leads to something called data rot. So it was clear that something better was needed. And not just a more accurate AI, but one that was transparent, one that you could trust, one that was built on a really solid foundation of clean data. It was time to build a smarter eye. So how'd they do it? Well, their new approach was broken down into 3 really smart stages. First, they had to make sure the data itself was pristine. Second, they needed an AI that could see the whole fruit, not just bits and pieces. And third, they needed a totally reliable decision maker. Let's break down how each of those steps works. Okay, step 1, data purity. It's so important. They used this cool digital fingerprinting technique to scan over 12,000 images, and they found and got rid out 44 exact duplicates. By doing that, they made sure the AI couldn't, cheat on the test by just memorizing the same image over and over. It had to learn from unique examples, just like in the real world. Now for the eyes of the operation. Instead of using a standard AI that just looks at an image pixel by pixel, they use something called a vision transformer, or VIT for short. And what makes a VIT so special is that it sees the entire image all at once. It gets the whole picture, understanding the relationship between the base of the fruit and its tip. It understands the global context, which is absolutely crucial for judging something this complex. So you have this powerful vision, but you need a decisive brain to make the final call. The VIT takes all that crucial visual info and crunches it down into a data point. Then it hands that off to a support vector machine, or SVM. Now, an SVM is a classic, powerful classifier that is brilliant at one thing: drawing a clear, sharp line between categories. No gray areas, just a final, confident decision. Raw, ripe, or defective. Okay, so we've got this really elegant, thoughtfully designed system. It's built on clean data, it's got powerful vision, and a rock-solid brain. But this is where we get to the moment of truth. After all that brilliant engineering, all that careful rethinking of the entire process, how well did it actually do the job? The answer, 99.84% accurate. That is almost perfect. Out of thousands and thousands of images, it barely ever made a mistake. Just let that number sink in for a second. And listen, this wasn't just a tiny improvement. You can see from this table, this new system didn't just nudge past the old models like ResNet 50 or Densnet 201. No, it completely set a new, much higher bar for accuracy in this field. And this image explains why it's so incredibly accurate. Think of this plot as a map of the AI's brain. Each little dot is a different dragon fruit image. And you can see it has learned to group them into 3 super distinct clean clusters: defective, raw, and ripe. There's almost zero overlap or confusion between them. And because those clusters in its mind are so clean, the real-world result is just stunning. This is the confusion matrix. Look at this. Out of over 1,200 test images, it made a grand total of 7 mistakes. And check it out, a perfect record on spotting defective fruit, which, as we know, is the most critical one for preventing those financial losses. But here's a fair question. Is it just getting lucky at matching patterns, or is it actually intelligent? Well, an explainable AI audit answered that. They looked at what parts of the image the AI was focusing on, and it turns out it's looking at the exact same clues a human expert would. The green tips on a raw fruit, that deep magenta color of a ripe one, and the obvious spots and lesions on a defective one. It's not just accurate, it actually makes sense. This level of performance, this kind of transparency, it's a huge leap forward. But the real story, the real impact, is what happens when you take this tech out of the lab and bring it back to the real world. And here you can see it in action. This is a random sample of test images, with all the weird lighting and different angles you'd get in real life. And the system nails every single one of them. This isn't some fragile lab experiment. This is a robust tool that's ready for the messy reality of a farm. So, at the end of the day, this is so much more than just a research paper. It's a real tool that can directly reduce the financial hardship of farmers, help ensure the quality of the food that we all eat, and bring truly cutting-edge technology to the people on the ground who need it the most. And that really leaves us with one final big question. Now that we know we can build AI that isn't just mind-bogglingly accurate, but is also transparent and trustworthy, what other critical, hands-on problems in our global food supply chain are just waiting to be solved?